Yep. Hello, everyone. My name is Eric Arneson, and I'm here with my partner, Nahal Sabati. We're from Topophyla. We're a small boutique landscape design firm in Santa Barbara. And today I'm going to be talking about drone-aided design and the many applications of drones in landscape architecture. So currently, there are two major realms that drones can be used professionally. The first one is art, and the other one is the sciences. So art is mainly visual things such as photography, cinematography, things for real estate and marketing. Scientific applications would be more for research, analysis, surveying, forestry, things that are more driven by data. And since landscape architecture is the application of both art and science, it uniquely benefits from the use of drones in our profession. So currently, landscape architects and designers use software that can already be used with drones. So things like Photoshop can be used for photo manipulation, Rhino 3D can be used for 3D modeling, AutoCAD can be used for technical drafting and drawing. But with the application of third-party software such as Drone Deploy, Pix4D, or Maps Made Easy, which take advantage of the drone's GPS capabilities, you can create high-end 3D models and site surveys of your project sites. So first, the most apparent use of a drone is for aerial photography. Drones nowadays come equipped with very high-quality 4K cameras that can capture really amazing photography right out of the box. This is a project by CMG in San Francisco. Another application for aerial photography would be to gather site imagery for site analysis and presenting that information. So this is an aerial photo from a project site in San Francisco. They were able to create an overlay of concepts and diagrams for presentation to a public community project. Another way to use aerial photography is for before and after renderings. So in this example, I took a photo from a project site and I noted down at what elevation I was taking the photo, which angle the photo was pointed, and the full field of view of the camera. And I was able to match that view exactly in SketchUp and then overlay that rendering in Photoshop to create a perfect before and after rendering, which is a great tool because you get all the accurate context and it really helps the person who's viewing it understand what the design is. So here's some other examples. So the ones on the left are the existing site and the ones on the right are Photoshop and 3D model overlays of the exact same view that the drone took. This can be used in other rendering softwares. Stuff like Lumion is also very good to use with this. Another application would be for construction administration, construction observation. So you can fly the drone over the site and understand better how the site is being constructed and built over time. So to go beyond just the photo capabilities, you can also take really high-end videos with the drone. These can be narrated over, so you could do like a site tour from the sky and share that with your team or your client. And you can also live stream from some of these drones, so you could theoretically share the view that you're seeing from the drone with your team, possibly the architect in Germany and the landscape architect in Australia, and they could all be on call saying, go look at that point over there, or that point over there. It's a really exciting tool that I've yet to explore, but is possible. And to go beyond just a single view from a camera, the future, I imagine, will be 360 cameras built into these drones. So a 360 camera is basically multiple lenses which capture everything around it. So if that is equipped on a drone, you can acquire every view from where that drone is flown. And this could be a great tool for everything from presentation to site analysis and beyond. And here are some examples of a 360 photo of a project site in Healdsburg, California. And then I also did an overlay of that 360 photo in Photoshop. So you can do before and after photos even with these 360 photos. There's another example, what a 360 photo looks like when everything is in view. And this photo right here is actually a stitched together composition of over 30 images, which have been manipulated in Photoshop to be one compiled image, which is about 200 megapixels large. It's very massive, so you can actually zoom in to different points and see what they look like. So this is that same photo on Google Earth, and as you can see, you can zoom in very high quality to whatever view you want from that point. This is a great tool, say, if you went on a site visit. This way you can capture everything within view, so you don't have to go back and say, oh, I missed that view, what was there? So you can go back and see in very high quality. Okay. So that was the artistic applications of the drone. Now we're going to go into more of the scientific and data-driven uses. So drones are a great tool for mapping. Many people use them for mapping, such as site surveyors. But we as landscape architects can also use this technique. And this one here, this example, is actually the image that on the top left is actually a series of 10 images that have been photoshopped together to be one orthomosaic image, which is a view looking straight down, so everything is the same dimension. It's not distorted by the field of view of the camera. And this is a great tool for creating quick overlay base plans for your designs. And there's an advantage of this over Google Earth, which is the resolution is much higher. And we'll go into the detail of that later. And this is also, you're able to get current data, current information of what the site looks like right then when you're taking the photo, versus Google Earth, which may be delayed depending on when the satellite photos were taken. And to take that even further, with the application of third-party software such as Drone Deploy, which use the GPS coordinate to create very high-end technical maps. And how that works is each photo is taken, it has a GPS tag on it, so it knows exactly when and where that photo is taken in X and Y axis as well as vertical elevation. And what it can do is create very helpful and accurate base maps. And how it does that is with photogrammetry, which essentially works how your eyes work with stereoscopic vision. So you have two eyes, which creates a 3D effect. And then just imagine that multiplied by hundreds of photos. And that's how essentially these 3D models are built. And for resolution of these maps, we have a picture on the left, which is Google Earth, which is about 30 to 50 centimeters per pixel. So each pixel is about 30 to 50 centimeters. Whereas a drone map can be up to 1 to 5 centimeters per pixel, so almost 30 times more clarity. And just one application of this mapping feature is you can take the same site and map the exact same route multiple times. So this is a great tool for, in this case, seasonal mapping, where we mapped a park in Berkeley over 3 different seasons. So fall, winter, and summer. And it was a great tool for understanding how the ecology of the site fluctuated throughout the seasons. And with the advancement of new softwares and technology, machine learning will become a tandem technology that will increase the application of drones in our profession. In this example, machine learning can be used to count trees from these 3D surveys. And how it does that is the machine learning can recognize what a tree looks like, and by doing that, the more it does it, it can better recognize trees and call them out on these 3D plans. So in this example, it's able to call out which objects are trees and which ones are deciduous trees, and it even calls out vehicles. And this is just a beta level software that will still be advancing in the future, and this is what I think we have to look forward to as what we can use as a tool. And to bring that even further is NDVI mapping, normal differentiation vegetation index, which essentially measures the amount of chlorophyll, the green amount in a plant leaf. And this is a great way to analyze plant health over a very large area. Farmers use this extensively for monitoring crop health, and I think landscape architects could also use it to monitor recent installations of plants or maybe existing groves of trees for possible infestations, where they could assess which trees to keep or remove on large project sites. So with the photogrammetry, you get a very high-end 3D model, which is essentially a mesh of the shape of the object that you've scanned, but with the image overlaid on it, kind of like a drape. And you get an OBJ file format that you can then manipulate in software like Rhino to edit the mesh. And you can also 3D print these site surveys. And here are just some examples of projects that I've scanned. And here is one in Rhino, just so you can see what it looks like. It's pretty high detail. And one of the biggest limitations of these 3D scans with photogrammetry is that it actually reads vegetation as a solid. So you can see the vegetation, these trees here, are reading as a solid. So if you're looking to get contours for a project, it's best if the site is void of any plant material or structures, because it will scan those as well. But if you're looking to get heights of trees or anything like that, if you're just looking to get measurements of everything, this is an incredible tool. And here's some examples of 3D prints of the model. This is a great way, I think, for maybe community projects to help the stakeholders of the site or project understand, like, in a tactile way of what the site, how it's shaped, and maybe they can understand it better. And here's an example of site topography that I extracted from a drone scan. And essentially, that works by slicing the 3D model in certain intervals, and that's why you can get whatever desired topographic interval that you want. In this case, just 1 foot contours sliced through on a 3D scan of a project site. Here's an example of that 3D model I shared on Rhino. And as you can see, the areas without vegetation are very clean, and you can get very accurate topographic lines. And I've actually compared these with existing site surveys for some projects, and in some cases it's been more accurate where there's no vegetation. But where you can see where the trees are, it's just a mess. And where the buildings are, you can actually see it scans almost like in a pyramid, so you can see the peaks of the roof. So this could be helpful for analyzing the slope of a roof if you want to do solar studies or anything like that. And with these 3D models, you can also measure the volume of spaces. So this example here is a gravel mine. I was able to calculate the void of an area and also the positive mounding of an area. And if I wanted to do a cut and fill situation here, there's negative 2,000 cubic yards. And in this point here in the blue, there's about 2,000 cubic yards. So if you're going to cut and fill that, you need an extra 18,000. So this is a really quick way to calculate volumetrics for project sites, which is a lot easier than doing it the old-fashioned way. So here's a case study for a project that we worked on. It is a 4-acre site in Forestville, California. The client was on a really strict budget, and they didn't have an existing site survey or base map to provide us. And also the Google Earth imagery was obstructed by clouds, and it was out of date because they did some recent constructions. So we decided to provide our drone mapping services to provide a supplemental base plan. So how that works is you select the area, and then you plug it into the application. In this case, it was Drone Deploy. And it will set an automatic route. In this case, it was a zigzag pattern, which is the fastest way that it can take the photos that are essentially overlaying to get that photogrammetry scan. And in this application, it took about 5 minutes to map the 4-acre site. So that saved us about, I would say, about 6 hours of out in the field, just out there measuring by hand. So that was a fantastic tool. So then we had to go home and process that data online, which essentially just upload the photos, and it does it for you, and it spits out some data sets in a few hours through the software. So here's the 3D model. And with that 3D model, you can slice it and get the contours that you need. So this was incredibly helpful for the project. There was some flooding issues on the site, and we were able to alleviate that based on the data that we got from this scan. And the client was completely unaware that there was about a 20-foot grade change from one point of the property to the other. So this was helpful for them too, because they thought it was flat. And here is the orthomosaic map on the left, and then on the right is the contours, and then overlaid with what we traced out the outline of the structures. And we're able to get a very helpful base map that we could then create some concept designs from. And with that 3D model, you don't just get X and Y axis measurements, you also get vertical and angles. So this also helped us for measuring the angles of the buildings, where the windows were, so we could accurately represent their architecture, existing architecture in our projects. So as technology advances, these drones become ever more a part of our life and in many other fields, not just landscape architecture. But as landscape architects, we should bring it upon ourselves to incorporate as much new technology as possible to provide the best services for our clients and for the public. So, thank you.
So at this point, if you guys have any questions, I think you guys can take questions.
Yeah, I'm happy to.
Thank you so much for coming. We really appreciate it.
Yeah, thank you, Brian, for having us.
Yeah,
this
of course.
is a pleasure. Yeah, any questions? Definitely. So right now, drones range from about anywhere from $500 to upwards of $10,000, depending on what capabilities you're looking for. The one that I use is a Mavic 2. This one is about $1,500, which has pretty much all the features that you need as a landscape architect. Has an amazing camera, and it's able to do all the mapping capabilities that you just saw. Once you go under $1,000, I think you're going to be more limited to the quality and the amount of range that you can reach with the drone. So I think about $1,000 would be the starting point for a landscape architect. And as far as laws, I am a licensed FAA drone pilot. In order to fly commercially, which means if you make money flying a drone in any scenario, you technically need to be licensed with the FAA, which entails taking a test which is about 100 questions at an FAA test center, which usually at some certain airports. And that's basically just about drone regulations and laws, which you just asked about. So you need to be knowledgeable about airspace laws, where airplanes are flying. They don't care if you know how to fly the drone. They just care if you know how airplanes are flying. They don't want you being anywhere near any airports or airplanes and interfering with actual important stuff to them. So, yeah.
Okay. Are you? Can you hear me fine without?
Yeah, I can hear it fine.
We're taping it.
Oh. Okay. Are you aware of any other firms that use this technology? Because I've never heard of this before. Oh, I mean, I've heard of drones, but not using it in the landscape setting.
Yeah, right now I'm aware of a few firms that use them professionally. Maybe not much mapping, but they definitely use them for photography. So one I see most is for marketing of their project. So they use the drone to take a beautiful photo that they put on their website. But for mapping, I've noticed that Rios Hail Clementi is one that I saw that did use it for a little bit of mapping. And then some off the top of my head, I think I saw EDSA using it at one point. But that's who I'm aware of. And it'll definitely increase. You'll see a lot more. And I think if you have this skill and you add it to your resume, it'll be a great hiring point for offices.
Along those lines, if it's such a new field, I know you were saying that when you were a student, you got in trouble for calling it a land survey.
Yes.
So what's the legality now? Can you use it for like a public project? Can you use it for your CAD documents? How's that?
That's a good question. As far as legality, first of all, you need to be an FAA licensed pilot. Beyond that, if there's public projects, there's a huge gray area depending on which city you're in, where you're located, if it's even legal to fly. Some areas you're not allowed to fly, such as federal parks. State parks are a little gray. The policies are always changing since this is a new technology and pretty much a new profession, being a drone pilot. But, and also insurance is a huge issue, that you should be insured as a pilot in case your drone crashes and causes an accident or something like that. Is that? Oh, sorry, what was the other question?
More about like being able to use the data that you get from the mapping in professional drawings.
Yeah, by no means do the maps that these drones create replace a site survey in any condition. This is a great tool for a supplemental something that's supplemental to a survey. So say you're working on a project where there's no significant grading that needs to be done, or they just need a concept design. This would be a great tool for getting an accurate base map for that. Or if you're waiting on a site survey and you want to begin the design, this would be a great design, kind of like the concept phase, to utilize this technology. But as far as like using this strictly for your site survey, I would not. It doesn't replace it at all.
So I really agree that this is a great tool for landscape architects, like of any kind. But I think the thing that confuses me is like how you would begin the process of integrating this into a firm, whether that's like smaller or bigger. So what was your process for integrating this into your design?
That's a great question. So how we've gone about integrating this into our design process is that we treat it as a tool typical to a camera, a measuring tape. We bring it with us to every site visit we have. We talk to the client, we make sure that they're okay with us flying it, and if not, we don't. If they're okay with it, we do. And it's proven incredibly helpful for our design process, as we can go back into these 3D models, take measurements. I mean, there's one project we're working on right now where we wanted to get spot elevations on a sidewalk, which was sloping, and we had no other way to get that because it was out of the realm of the site survey. So we were able to get that with the drone data. So we're just using it as a tool that we bring with us on every site visit. So just incorporating it into our daily workflow.
I was wondering, like, so you mentioned using Rhino as your modeler. Have you used other programs? Like, is SketchUp compatible with any of these files? Or?
SketchUp is, I think, very limited as far as editing OBJ files. It can become just bogged down. It's not good at processing that kind of information. I have tried it once or twice and it just didn't work. Yeah. That's why I've moved to Rhino, which is much faster and more capable of manipulating those objects.
So that would be your recommendation in terms of the program?
And the way that I've used it is that I've used essentially Rhino as a tool for measuring the model and maybe editing it, cleaning it up a bit. But then I bring everything into SketchUp, which is easier, faster to model. So like I'll remodel the architecture from the measurements I take in Rhino. And also the same with the topography. So I can extract the topo lines, then remodel it in a cleaner way. Because what you get exported on some of these 3D files is pretty messy because it's reading everything that's in the view of the camera. So vegetation, piles of rocks, sticks, whatever. Yeah.
Hi. Have you ever had to obtain a permit to fly drone in certain areas, and what's the process like to get a permit?
Yes, I did photography for the Seawall project in San Francisco for CMG, which is a very extensive, huge project in San Francisco, and we had to apply for a series of permits and proof of insurance. Because that was a public project in a high-profile area, there's a lot of exposure for risk of it crashing, things like that. So you do have to apply in certain situations. Yeah.
Do you then pass those costs like onto your client, or is that insurance that you guys hold at all times, so you're able to take on those
In
types
this case,
of jobs?
it was project-based insurance, because there's different insurance for drones right now. There's one that is a pay-as-you-go insurance, which I use, because it's just more affordable, because I'm not flying every day. I'm just maybe like once or twice a month. So that's more useful for me. You basically just say the area that you're going to fly when, what elevation, and they give you insurance policy for that day.
You previously shared with us that you first bought a drone with your other classmates at school. Is that correct?
Well, Nahal and I bought our own.
Oh, you bought your own. Okay.
Yeah.
How was it helpful to have this technology when you were still in school and use in projects? Like, how did it help transform your project work?
Well, it was an incredible tool. We used it on all the projects we could, as much as possible. And we did use it in both of our ASLA projects, the ASLA award-winning projects. And I think that helped because it created a huge improvement in graphic quality, because you had a very beautiful image that you're able to overlay your design over. So some of those examples I showed were ASLA projects. And I think that helped win over the judges. And also for us, it just helps us understand the site.
How difficult is it to learn how to use these different softwares and integrate it into your normal workflow?
It's a lot of experimenting, because none of this is, I mean, the drone software itself is very simple. You just upload the photos and it gives you this data. But using that data in a meaningful way is the tricky part. I spent a lot of time experimenting with and failing at using a lot of this data. So I would just say it's a lot of experimentation. You might find something that's much better than what I showed, and hopefully new software will come out that can manipulate the software. But right now it's just a lot of hit or miss. But I've come up with a solution with Rhino and measuring it there and then manipulating it with that. That works pretty well.
Any other questions? All right, thanks everybody for coming. And thanks again to Topophyla. We appreciate you guys coming and sharing all this great information with us.
All right, thank you guys.